Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2 November 2020. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let the other friend knows about my channel to support me. And let's get started. Chlorine undergoes many reactions. State the full electron configuration of the chlorine atom. Chlorine with the electron number of 17 has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p, 5. State, giving a reason, whether the chlorine atom or the chloride ion has a larger radius. Chloride ion, Cl minus, the number of electron becomes 18. Okay, but chlorine atom, the number of electron, it's 17. So chloride ion has one extra electron, makes chloride ion has a larger radius as it has more repulsion between electron because it has one extra electrons for the chloride ion. Outline why the chlorine atom has a smaller atomic radius than the sulfur atom. For chlorine atom, it has 17 electron and 17 proton, and for sulfur, it has 16 electron and proton. So the electronic structure is 287 and 286. Even though it has the same number of shells, it has 3 shells here, both of them, but Cl has more proton, causing stronger attraction between electrons and protons. Thus, chlorine has a smaller atomic radius because it has more proton, so more attraction from the nucleus with the electron. So it squeezed the size of the atom, therefore the atom atomic radius becomes smaller. The mass spectrum of chlorine is shown. Outline the reason for the 2 peaks at 35 and 37. So 35, it's Cl, and then it's 37, so it means it has 2 isotopes, Cl 35 and Cl 37. Explain the present and relative abundance of the peak at 74. So this one at 74 here. Okay, 74, we can get it by 2 times 37. So 37, sorry, this one 35 and then 37. Okay, so 74, you can get it by 2 times 37. It means it has 2 Cl37, because you know Cl, it's not one atom, it should be a molecule. So it is Cl2 molecule with mass number Cl37. The least abundant isotope, as you can see on the picture, is very low. So the least abundant isotope. 2.67 gram of manganese oxide was added to 200 centimeter cube of 2 molar HCl. We've got molar and we've got volume and we've got mole of manganese oxide. The question is calculate manganese oxide, mole of manganese oxide. So to calculate mole, M divided by MR, 2.67 divided by molecular mass of manganese oxide, which is 86.94. You've got 0.0. Determine the limiting reactant showing your calculation. These are the reaction: MnO2 plus 4HCl produce Cl2 and 2H2O, MnCl2, the one that from here. Okay, I just copy it down. So MnO2 and HCl, which one is the limiting reactant? From the previous question, we can calculate mole of HCl because volume and concentrations are known. So N HCl, C times V, 2 molar times volume is 200 centimeter cube, so 0.2 decimeter cube, so 0.4. So here is 0.4 mole. Therefore here 1/4 times 0.4, it's 0.1. Okay, now which one is the limiting reactant? When we compare with the previous question, 2.67 gram of manganese oxide was added. So actually the mole of manganese oxide, it's 0.0307. So it's very small. Therefore, MnO2 is the limiting reactant. Determine the excess amount in mole of the other reactant. So MnO2 plus 4HCl produce Cl2, 2H2O, and MnCl2. As we know, the mole of MnO2 is 0.0307. So this is the limiting reactant. So now to calculate mole of HCl is 4 divided by 1 times 0.0307. You get 0.123. So we minus this, for mole of HCl, it's 0.4 after we calculate from here. So only 0.123 just now. 4 divided by 1 times 0.0307. This is the amount of HCl that is reacted when 0.0307 mole of MnO2 is added. So the excess would be 0.0277. You subtract this mole excess. Okay. Calculate the volume of chlorine in decimeter cube produced if the reaction is conducted at standard temperature and pressure. To calculate volume of Cl2, we need mole times Vm. And now we see on the reaction, Cl has the same coefficient with MnO2. Therefore, it has the same mole with MnO2. So it's 0.0307 times 22.7, which is 0.697 decimeter cube. State the oxidation state of manganese in MnO2 and MnCl2. So this is -4 because -2 times 2, so this will be +4, should be 0. So this +4, and this one -2 because Cl is -1 times 2, so this one is +2, so +2. Be careful, not 4 plus or 2 plus. You will not get a mark if you write it in that way. Deduce referring to oxidation states whether MnO2 is an oxidizing or reducing agent. Okay, oxidizing agent, it means experience reduction. Reducing agent, it means it experiences oxidation. So MnO2 plus 4HCl produce Cl2, 2H2O and MnCl2. Mn here, the oxidation number is +2 and this one +4. We already calculated here. So +4 to +2, it's reduction. Therefore, oxidizing agent. It's always the opposite. If it's oxidizing agent, it's reduction. If it's reducing agent, it's oxidation. Chlorine gas reacts with water to produce hypochlorous acid and hydrochloric acid. Hypochlorous acid is considered a weak acid. Outline what is meant by the term weak acid. An acid that partially dissociate in water. Strong acid fully dissociates in water if it's strong acid. State the formula of the conjugate base of hypochlorous acid. So hypochlorous acid HClO, when it reacts with water, will produce H3O plus and ClO minus. So this do not or gives proton, so react as an acid. This is act as a base, and this one act as a conjugate acid, and this one conjugate base. So conjugate base of hypochloric acid, it's ClO. My conjugate base of hypochloric acid is ClO minus. Calculate the concentration of H plus aqueous in HClO solution with a pH 3.61. So H plus, it's 10 to the power negative pH, which is 10 to the power negative 3.61, which is 0.00025, or 2.5 times 10 to the power negative 4 mole per decimeter cube. State the type of reaction occurring when ethane reacts with chlorine to produce chloroethane. So ethane, CCH, react with Cl2. Okay, this Cl2 should split, produce radical to chlorine radical. So then it will substitute one of the H and produce HCl. So the type of reaction would be free radical substitution. Okay, because this Cl2 needs to be split and produce chlorine radical, and directly substitute one of the H. That's why it's called free radical substitution. Predict, giving a reason, whether ethane or chloroethane is more reactive. Ethane has the bond CNH. Chloroethane has CNH, but we focus on more C and Cl. Okay, so the one that is more reactive, it's CCl, or I could say the answer is chloroethane, because CCl bond requires less energy, only 324 kilojoule per mole. So it requires less energy to break than CH, which is 414 kilojoule per mole. Bond in ethane. So to break CCl bond, is much easier compared to CH, because CCl requires only 324, compared to CH, which is 414 kilojoule per mole. Explain the mechanism of the reaction between chloroethane and aqueous sodium hydroxide NaOH using curly arrows to represent the movement of electron pair. So it's chloroethane, CH3, CHH, and Cl. So OH minus, this will go here and this will go here, and it will produce Cl, OH, CH3, H and H in bracket, and then we'll produce CH3, CH2, OH, and Cl minus. So the OH minus is a nucleophile that is attracted to carbon and forms the transition state. The chemical in the bracket is considered a halfway step in the reaction due to atoms being broken and made continuously. It continues with the departure of Cl and produce alcohol. So Cl will be chloride ion, and the other product is the alcohol. Ethoxyethane or diethyl ether can be used as a solvent for this conversion. Draw the structural formula of ethoxyethane. Ethoxy, CH3CH2, O CH2CH3, ethoxyethane. So 2C ethane. Therefore, the structure will be CH3, CH2, O CH2, and CH3. Deduce the number of signal and chemical shift with splitting pattern in the HNMR spectrum of ethoxyethane. As you can see here, we've got two H environment. So this one and this one is the same because it's symmetrical, and this one is the same. So we've got two signals. If we refer to the data booklet CH3, so data booklet section 27, okay, this one, that would be 0.9 to 1 for CH3, and then for CH2 that would be 3.3 to 3.7 because R, O, and CH2. So ethoxyethane, there is CH2 right here, and then with O. That's why it's 3.3 to 3.7. So two signals, CH3 and CH2. So this one at 0.9 to 1 ppm, and this one at 3.3 and 3.7 ppm. For the splitting patterns, okay, CH3 is next to CH2. So next to CH2, it means triplet, and CH2 is next to CH3. It's quadruplet. If it's next to CH, it's doublet. If it's next to the C that has no H, it's a singlet. CCl2F2 is a common chlorofluorocarbon CFC. Calculate the percentage by mass of chlorine in CCl2F2. So we've got 2 Cl. So to calculate mass of chlorine, percentage mass of chlorine, we do 2 times Ar chlorine, because we've got 2 chlorine, yeah, divided by Mr of CCl2 F2. So 2 times 35.45 divided by 120.91 times 100, which is 58.64%. Comment on how international cooperation has contributed to the lowering of CFC emissions responsible for ozone depletion. So they do research collaboration for alternative technology to replace CFC, or they also do data to share, so they would be aware of what is actually caused by having CFC emission. You can choose one of them. CFCs produce chlorine radicals. Write 2 successive propagation steps to show how chlorine radicals catalyze the depletion of ozone. So propagation, when you produce the reactive molecule. So of course with Cl first we've got chlorine radical, so then for the propagation it will react with ozone, produce O2 and ClO radical. So the chlorine atom react with ozone, forming ClO radical that can further react with ozone molecule, cause depletion of ozone. So next, ClO radical will react with O radical, produce oxygen and Cl radical. The regeneration of Cl radical release also then go on to catalyze the breakdown of more ozone molecule. Okay, so these are the propagation steps, or if you don't want to write this one, you can also use or write ClO plus ozone will produce Cl radical plus 2O2. Both of them regenerate chlorine radical that will go on to catalyze the breakdown of more ozone molecule. So you produce, it keeps producing Cl radical, then it keeps reacting with ozone, produce ClO radical, and then the reaction keep going and keep going. Compound A is in equilibrium with compound B. Predict the electron domain and molecular geometries around the oxygen atom of molecule A using VSEPR. So OH, it has a lone pair, and this one with C. So it has 1, 2, 3, 4 domain. So it will be tetrahedral, and it has 2 lone pair. Therefore, the molecular geometry will be bent or V shape. State the type of hybridization shown by the central carbon atom in molecule B. So C here, it has 3 domain. It means the hybridization would be sp2. 4 domain sp3, 3 domain sp2, 2 domains sp only. State the number of sigma and pi bonds around the central carbon atom in molecule B. So we've got 1 single bond, 1 sigma, 1 single bond here, 1 sigma, double bond has 1 sigma and 1 pi bond. So 3 sigma bonds and 1 pi bond. The IR spectrum of one of the compounds is shown. You see here is around 1700 to 1750 centimeter to the power -1. So it's a C double bond O. Deduce giving a reason the compound producing this spectrum, the one that has C double bond O, it's B. So B, as it has C double bond O, absorption. Compound A and B are isomers. Draw two other structural isomers with the formula C3H6O. So two other structural isomers. So you need two. We can do CH double bond CH OCH3. Okay, or you can also do CHHC double bond C HOH alcohol, or you can also do CH3 CH COH. Okay, so you can choose two of them. So one is ether and another one is with the alcohol, and then the other one is the carboxylic acid. The key here, you need to have double bond and then O, and the number of C should be 3, and then H should be 6, and then it has to have one O. The equilibrium constant Kc for the conversion A to B is 1 times 10 to the power 8. So K is bigger than 1. Deduce giving a reason which compound A or B is present in a greater concentration when equilibrium is reached. So Kc, if it's bigger than 1, it means concentration of product, it's bigger than concentration of reactant. Okay, B is the product. It means concentration of compound B bigger than concentration of compound A, because K is bigger than 1. If K is more than 1, then compound A or reactant is bigger than the concentration of product. Calculate the standard Gibbs free energy change in kilojoule per mole for the reaction A to B at 298 Kelvin. To calculate delta G, it's negative RT ln K. It should be in kilojoule, so let's just convert R 8.31 joule to 0.00831 kilojoule per mole K times 298 times then 1 times 10 to the power 8. You will get negative 46 kilojoule per mole. Propanone can be synthesized in 2 steps from propene. So from propene, let's start from propene. And we need to produce propanone. Propanone is a ketone. So we need alcohol, which is secondary alcohol, to produce ketone, not primary alcohol, because primary alcohol will produce aldehyde and carboxylic acid. So we need to produce alcohol by adding water, because it will have OH in acidic condition. So CH COH. Be careful. So we need secondary alcohol, so we shouldn't add OH right here. And now we need to oxidize secondary alcohol using KMnO4 or K2CR2O7 potassium dichromate, but should be in acidic condition, and you will produce propanone. Suggest why propanol is a minor product obtained from the synthetic route. Okay, propanol, it's a product using primary alcohol. So when you do the oxidation of propene, producing, okay, during the oxidation of propene, producing primary alcohol is a minor product. Why? Because it is formed from primary carbocation. Primary carbocation is less stable than secondary carbocation. Okay, thus the production of propanol would be a minor product. If we see here, if we add OH right here, therefore only this C will attach only to one alkyl as a primary carbocation. But if we add OH right here, okay, so it has two alkyl, so secondary carbocation. That's why when it produces primary carbocation, which is primary alcohol, that would be a minor product, because primary carbocation is less stable compared to the secondary carbocation, and secondary carbocation would be less stable compared to the tertiary carbocation. But tertiary alcohol will not undergo oxidation, so there is no product and there is no reaction. An equation for the combustion of propane is given below. Determine the standard enthalpy change. Okay, so C3H8 and 5O2, 3CO2 and 4H2O. Then we can calculate here would be 8CH plus 2CC plus 5O, and so this CO R2 is 2, so it will be 6CO, and the same with OH, so 2 times 4, 8OH. So that would be 8 times 414 plus 2 times 346 plus 5 times 498. The 6 times 804 plus 8 times 463. Okay, so you've got 6494 and this one 8528. So delta H 6494 8528, you've got negative 2344 2034 kilojoule. Calculate the standard enthalpy change delta H for this reaction using section 12 of the data booklet. So we need propane, oxygen is 0, CO2 gas and H2O gas. So we need propane and then H2O, but it should be gas, and then CO2. Okay, so delta HF for water but steam, it's negative 241.8, and for propane it's negative 105, and for CO2 gas negative 393.5. So delta HF is delta H product minus delta H reactant. So if we refer to this that would be 4 times negative 241.8 plus 3 times negative 393.5, so 3 CO2, minus propane, which is negative 105, and you will get negative 2443 kilojoule. Nickel catalyzes the conversion of propanone to propan-2-ol. Outline how a catalyst increases the rate of reaction. It provides an alternative pathway and lower deactivation energy. Explain why an increase in temperature increases the rate of reaction. Because when you increase the temperature, it will give more proportion of molecules with energy that is bigger or the same with activation energy, and this will cause greater frequency of molecules. Discuss referring to intermolecular forces present, the relative volatility of propanone and propan-2-ol. For propanone, as you can see the structure, okay, it has C double bond O, but for propan-2-ol, CH3, CH2, CH2, and OH. So in propanone, it exists dipole forces, but for propan-2-ol, it has hydrogen bond. Thus, propanol is less volatile due to hydrogen bonding is stronger than dipole forces. The diagram shows an unlabeled Voltic cells for the reaction. Pb2 plus Ni produce Ni2 plus and Pb. Label the diagram with the species in the equation. Ni, nickel, is more reactive than Pb. Therefore, Ni will experience oxidation. Oxidation is at the anode. So Ni will be here, and Ni2 plus is the solution. Therefore, here is Pb, and this will be Pb2 plus. So here we'll have oxidation, and here it's reduction. Okay, calculate the standard cell potential using section 24. So we've got Ni and Pb. So Ni negative 0.26, Pb negative 0.13. So E cell will be reduction minus oxidation. So reduction is Pb, which is negative 0.13, minus oxidation, which is Ni, negative 0.26, and you've got 0.13 volt. Calculate the standard free energy change delta G in kilojoule for the cell using sections 1 and 2 of the data booklet. So delta G will be NFE. It has 2 electrons here, Ni2 plus or Pb2 plus, so only it involves 2 electrons, and F 96,500 times 0.13, you've got negative 25,000 joule or negative 25 kilojoule. Suggest a metal that could replace nickel, that is more reactive compared to lead, in a new half cell and reverse the electron flow. It means we need to find a metal that is less reactive compared to lead. So from this, all of this metal, for example, Cu, copper, silver, or platinum, or gold, that could be the answer. So it could be Cu, or Ag, or Pd, or Hg, or Pt, platinum, or Au, as long as it's less reactive than Pb. Describe the bonding in metals. It is electrostatic attraction between a lattice of metal ions and a sea of delocalized electrons. Nickel alloys are used in aircraft gas turbines, suggests a physical property altered by the addition of another metal to nickel. It could be density, or hardness, or strength. You know, a metal has a regular arrangement structure where the layer can slide over one another. So this will cause a metal can be hammered into a shape or drawn into a wire or ductile. But once you add another metal in the regular arrangement, so the atomic radius or the size of the atoms would be different. So it's not a regular anymore. Therefore, the layer cannot slide over one another. And this will make the alloy becomes more dense or more hard, because now cannot be bent into a shape anymore, cannot be hammered or drawn into a wire. So it also more strong compared to regular metal, or I mean when it is not alloy. A student performs a titration to determine the concentration of ethanoic acid in vinegar using potassium hydroxide. Write a balance equation for the reaction. So that would be CH3COOH aqueous plus KOH aqueous will produce CH3COOK aqueous and H2O. So this is CH3COOH COO minus and H plus, this K plus OH minus. So you can just add K right here, because positive ion will combine with negative ion, and H plus and H2O and OH minus will form H2O. This will be liquid. Identify the major species other than water and potassium ion. That would be CH3COOH and CH3COO minus. And for C would be CH3COO minus. Here only CH3COO minus, because the titration has not started yet. And here is the half equivalence point. It means there will be CH3COOH and CH3COO minus, because few weak acid already partially dissociate and few of them has not partially dissociate yet. And then for this one, that would be the equivalence point. So the weak acid already dissociate, so that would be only CH3COO minus. State a suitable indicator for this titration, because is the titration between weak acid and strong base, the pH should be bigger than 7. So the suitable indicator will be phenolphthalein. Suggest giving a reason which point on the curve is considered a buffer region. This one. Okay, B. Because the region where small addition of base or KOH result in little change in pH. So there is no high jump for the pH yet. So the pH is relatively stable. That is the buffer region. State the Ka expression for ethanoic acid. So that is KaCH3COO minus and H3O plus, and this one CH3COOH. Okay, calculate the Kb of the conjugate base of ethanoic acid using section 2 and 21. So Ka of ethanoic acid, if you refer to the section 21, that would be 4.76. So Ka is 10 to the power pH, which is pKa, which is 4.76, and you've got 1.7 times 10 to the power negative 5. You know the equation, K times Kb. This one is 1 times to the power negative 14, and we know Ka 1.7 times 10 to the power negative 5 times Kb. So Kb would be 5.8 times 10 to the power negative 10. In a titration, 25 centimeter cube of vinegar required 20.75 centimeter cube of 1 molar potassium hydroxide to reach the end point. Calculate the concentration of ethanoic acid in vinegar. We've got volume of potassium hydroxide and concentration of potassium hydroxide, so we can calculate mole of potassium hydroxide, which is C times V. So 1 times 0.02075 decimeter cube, which is 0.02, okay, I just make it 0.8. So NKOH is the same with NCH3COOH. Okay. So NCOOH the same with NKOH. Therefore, concentration of CH3COOH will be 0.0208 divided by volume of vinegar, which is 0.025 decimeter cube, and you get 0.830 mole per decimeter cube. Potassium hydroxide solution can react with carbon dioxide from the air. The solution was made 1 day prior to using it in the titration. State the type of error that would result from the student's approach. That would be systematic error. Okay. Predict, giving a reason, the effect of this error on the calculated concentration of ethanoic acid. Because potassium hydroxide solution can react with carbon dioxide from the air if you make it 1 day before. So the amount of potassium hydroxide will decrease because it reacts with carbon dioxide from the air, resulting higher concentration of CH3COOH, right? Thus, larger amount of KOH needed to neutralize the acid, because the amount of KOH decreases as it reacts with carbon dioxide from the air. The electron configuration of copper makes it a useful metal. Determine the frequency of a photon. So first we need to calculate the energy. So the first ionization energy of copper, if you refer to the section 8 of the data booklet, you've got 745 kilojoule, which is 745,000 joule. So to find the energy, so 745,000 joule divided by Avogadro's number. So this for one photon. So 1.24 times 10 to the power negative 18 joule. So to find the frequency, so we've got this number 1.24 times 10 to the power negative 18 joule, and H Planck constant, which is 6.63 times 10 to the power negative 34 joule second, times V. So V will be 1.87 times 10 to the power 15 s to the power negative 1, or hertz. Explain why a copper 2 solution is blue using section 17. In section 17, you can see the color wheel. So the copper's 2 solution is blue. It means orange color is absorbed. So orange light is absorbed, and the complementary light is observed, which is blue. Copper also has partially filled d orbitals. So ligand or water here, because it's solution, cause d orbital to split, so absorb light as electron move to a higher energy orbital. Okay, copper plating can be used to improve the conductivity of an object. State, giving your reason, at which electrode the object being electroplated should be placed. Whenever you want to collect a mass or to coat an object, it should be at the cathode, because Cu plus reduce at the electrode. So this the electrode, and then this, for example, the object, let's say key. So the electron will be produced here and move towards here, and it will collect the mass from the electrode here. So because it gains the electron, so it should be cathode, because cathode will experience reduction, which is gain electron. So always the object that is going to be coated should be placed at the cathode, and the one that will lose the electron will be at the anode. Nitrogen monoxide reacts with oxygen gas to form nitrogen dioxide. Deduce the partial order of reaction with respect to nitrogen monoxide and oxygen. For nitrogen monoxide, these are the same. So between this one, so 3, and this one, so 19 divided by 19.2 divided by 2.13, you've got 9. So 3 to the power 2, therefore the order is second order. And then oxygen, that would be between this, so this is 2, and then this one also 2, so double the concentration would be double the initial rate, so that would be first order. Okay, so the rate of reaction would be K NO to the power 2 and then O2. All right. Deduce giving a reason whether the following mechanism is possible. So slow will be the rate determining step, and O2 will not be counted because it is fast reaction. Therefore, the rate will be K NO to the power 2, but there is no oxygen, so it's not possible as the mechanism does not match experimental law, because in the experiment we've got oxygen first order, but here oxygen is not counted because it's a fast reaction. So the rate only K, only NO that would give an effect to the rate of reaction. Therefore, it doesn't match with the experiment. Alright, that's all for the explanation for the paper 2 higher level November 2020. I hope this video is helpful for your exam preparation or revision. Please don't forget to subscribe and let your other friend knows about my channel. Thank you for watching, and bye.